about chemistry. So the food we are having every day, it is a craft and art and also a science. So the food taste that you're getting from your meal, it's also related to some chemical reactions. So basically, instead of using the Bunsen burner and beakers in our lab setting, instead you're just using the pans and the stove tops. And then I'm going to just briefly introduce some chemical reactions during the cooking or baking. First is about the fermentation. So that's the carbohydrate molecules break down without using the oxygen, and they usually don't require the heat, or sometimes you put the stuff at 37 degrees or a little bit hot but not very heated condition to have the fermentation happen. And the living organisms are responsible for this process. So as you can see from the pictures here, the beer, the yogurt, and also those buns are also involving the process of fermentation. So that's a pretty straightforward one that I think everybody can just imagine what's going on in this process. And then the second common chemical reactions is the Maillard reaction. It's a Browning reaction occurs when proteins react with reducing sugars by the high heat. So it's going to have a appealing golden brown color. Considering the process when you cook the meat, when you have the oil in the pan, and you put the beef on top of the pan with the oil, and then you're going to have the Maillard reaction going on there when you're seeing the surface of the beef changing from the regular fresh red color to some brownish color. And a lot of other reactions also involve this Maillard reaction. The third one is the caramelization. It's heating the sugar molecules in low moisture, and that's all about the sugar, and it's creating darker colors, richer flavors, and alluring aromas that can sweeten up any meal. So like the pictures here, the group on the left-hand side, that's a process when you have the sugar with some water and then you heat it up. As the water evaporates, you're seeing also the color of the sugar becomes darker and darker. So basically, you're making some syrup during this process as well. And at the end, when all the water evaporates, you're going to have the final product. And on the right-hand side, that's also the other process. When you have the pudding, you use the high heat to heat up the surface, and you have this caramel on top of that. And in our Chinese cooking, by having the group showing here on the top left, we also use this product to give color to the meat instead of using the soy sauce. And then the fourth reaction that's very commonly used during the cooking is the gluten formation. So basically, two specific proteins, they are mixed with water to have this process going on. And then gluten is the one to trap the gas bubbles within the dough during the fermentation. So basically, adding water to the flour, you get the fermentation, and you have the gluten to make and hold the shape of your dough in order to go to the next process to make the bread or make the buns, make the pizza, or even that's involved in making the pasta. Next one is the protein denaturation. That's the physical changes that take place in the protein exposed to abnormal conditions. For example, the heat, the acid, the high salt concentrations, the alcohol, and the mechanical agitation. And simple example is when you're making the egg, either you fry it or you just boil the egg. So you're applying high heat to the egg to make the protein denatured during the process. And in the other way, for example, when you are making the cake, you have the egg white you stirred and form the foam. That's the mechanical agitation to denature the protein. And this is gonna give you a very kind of sponge taste of the cake by having those formed egg white in the recipe. The next common chemical reactions that we usually have during the cooking and the baking is the emulsification. That's a process where one liquid being dispersed as a small spherical droplets in a second immiscible liquid. And it is an essential and versatile cooking technique to combine two or more liquids that usually cannot mix by not using the emulsifier. So the pictures here, for example, the butter, the egg yolk, they are both the main parts which could be used as the emulsifier. And the common thing in our daily life, such as the ice cream, they need the emulsifier in the recipe to have the final product made. So that's all the chemical some of the chemical reactions that we may have or play with during our cooking and baking. And that's something I want to just share, and happy to discuss if you have some fantastic ideas about cooking and baking. Thank you.
Thanks, Tammy. Nice presentation.